Um, in order to find the x's of the graph, you need to find where the graph crosses the x-axis and where it also has a slope of 0. Each of these dotted lines is where the graph reaches the slope of 0 or crosses the x-axis. Then you must find if f prime is positive or negative. Like this one is above the x-axis, this one's below the x-axis. Then for f double prime, you find if f double prime is positive or negative depending on the slope. So right here it's negative because it's sloping down, and over here it's positive because it's going up. Now in order to find the local minimums, you need to find when f prime goes from negative to positive, and the only place that occurs is at 1, right here, negative to positive. To find inflection, it's when the signs change, but it's only at f double prime. So the signs change at -3 right here and at 3 over here. To find the intervals that concave down and have a negative slope, the concave when it concaves down, it must be an upside down U like that with the negative slope going this way. So the only place that this occurs is when f prime is negative and f double prime is also negative. So from -7 to -3 and 5 to 6 down here, because sooner or later it's going to go up. When I have to sketch out this graph, the reason it has the way it's shaped this way is because back to the first graph of these numbers that we wrote down depends how this graph will be sketched out. So since it starts with negative positive, f prime decreases, meaning that especially when f double prime concaves down, so it's going to concave down with negative slope, and the next one would be positive concaving upwards with the same thing. In this graph, f prime is below the x-axis, also below on the negative side, and finally hits the positive, negative. So all these portray that. Double prime is when the slope is positive or negative. So here's positive, 0, negative, positive, 0, negative. So that's where I got these. To find the local maximum, f prime needs to go from negative to positive. So the only place where f prime goes from negative to positive is right here at 0, between these two. In order to find points of inflection, f double prime needs to change signs, and it does so in 3 places. And to find the intervals from which it concaves up with the negative slope is -8 to 5 right here. And when f prime is negative and f double prime is positive, as well as -2 to 0 right here. Once again, have to find the points at which the slope is 0 or crosses the x-axis. There's a couple of them all right there listed. The intervals on which the graph, this is actually a graph of f double prime, so the only way to find, you have to find the concave of it going up, which is from -7 to -6, -2 right there, up until +2 right there. It's at any point from which these are positive. So another one would be 4 through 8, which is from here to here. The intervals at which it concaves down are just the ones that I did not list, which are -6 to -2, and 2 to 4 right here, and from here to here. Anything underneath the negative sign. In order to find inflection, the signs must change from positive to negative or negative to positive, and it's at -7. It changes at -6 because right here it goes from positive to negative, at -2 from negative to positive, at 2 positive to negative, and at 4 from negative to positive. This occurs because the signs change, as I just said.